Hi everyone, we're continuing with section 4.7 on inverse trig functions, and we're now going to discuss two groups of inverse properties. Let's remember inverse properties for other functions. So for example, what is the cube root of the cube of x for all real values of x? This is just x, because the cube root function and the cubing function are inverse functions. They undo each other perfectly. What about ln of e to the x? We see here an exponential function rule. We see here a log function. We have here a pair of inverse functions. This simplifies to x by an inverse property. And this is true for all real values of x. So under what circumstances will these be true? When will sine of inverse sine of x equal x? When will cosine of inverse cosine of x equal x? And when will tangent of inverse tangent of x equal x? It's under these circumstances. And what's an easy way of saying this? Basically, x here, the argument in here, is asking the outer function, am I in your range? If the outer function says, yes, you're in my range, then the outer function will go ahead and spit that argument out. So what is the range for the sine function, this outer function? It's the closed interval from -1 to 1. These are the sine values. So if x is in this interval, then x will be the output. Likewise, if x asks cosine, am I in your range? When is x in the range for the cosine function? Again, when x is in the same interval, from -1 to 1. These are the possible cosine values. So under these circumstances, the output will be x. When x here asks tangent, am I in your range? Tangent is very liberal. Tangent says, hey, every real number is in my range, because any real number can be a slope. Positive, negative, 0, a million, negative a million. The range for the tangent function is all real numbers. So we have these very nice inverse properties for group 1, provided that x, the inside argument here, is in the range of the outer function, sine, cosine, or tangent. Otherwise, your answer will be undefined. For example, if you try to put a 3 here, the inverse sine of 3 is undefined, or not real, and you're dead right there. The answer will be undefined. That's the case for these top two. For this third one is very liberal. You can put in any real value for x, and you'll get that result as your final output, because tangent is so liberal. As an example, what if we put a 1 here? I claim that you get 1 as an output. We can see that in the picture we saw earlier. Here's the inverse sine function, down here in blue. If you input a value of 1, that's a sine value, the output will be pi over 2, because the inverse sine of 1 is pi over 2. We've certainly beaten that into the ground. And then, if you take the sine of pi over 2, the result is 1. So we're basically saying that, okay, the arcsine or inverse sine of 1 is pi over 2. Okay, that's what this says over here. If you input 1 into inverse sine, the output is pi over 2. And if you take the sine of arcsine of 1, you're taking the sine of pi over 2, and the sine of pi over 2 is 1. So the sine of arcsine of 1 is 1. Arcsine of 1 is pi over 2. You take the sine of that, and you're back to 1. Your final output was your inside input. And again, this works beautifully as long as you have a legitimate sine value. Or if you have cosine and inverse cosine, a legitimate cosine value, it's the same set of numbers, the closed interval between -1 and 1. If you're dealing with tangent and inverse tangent, this could be any real number. And then the final output will be the number, the input. Let's look at some examples. All right, example. The cosine of the inverse cosine of 0.2. The cosine of the inverse cosine of 0.2. The answer will be 0.2 because the inside argument here, 0.2, is asking the outer function cosine. Hey, am I in your range? Cosine says, yes, you're in my range. You are a cosine value. You're between -1 and +1. So I can spit you out, and I do spit you out. The answer is 0.2. It's you. Of course, this works because we have cosine here and inverse cosine there. If you mix up functions, if you have, for example, sine here and inverse cosine in there, then we need to use a right triangle approach, which we'll discuss in a later video. By the way, if we have sine and inverse sine, the result will also be 0.2. Now, cosine of inverse cosine of 10. Well, 10 asks cosine, am I in your range? Cosine says, no, because you're not between -1 and 1. You're not a cosine value, which means I cannot spit you out, and this overall expression is undefined. Inverse cosine of 10 is dead right there. Finally, tangent of inverse tangent of 10, that is 10. Because 10 asks tangent over here, hey, am I in your range? And tangent is very liberal. Tangent says, hey, every real number is in my range. So if you're any real number, I'll spit you out. And 10 does get spit out. Again, it's important that we have tangent here and inverse tangent inside here. If we had something like inverse sine or inverse cosine in there, then we use a different technique. Actually, inverse sine of 10 and inverse cosine of 10, you're dead meat. That would be undefined, and the whole thing would be undefined. If this were a value like 1/2, for example, then we might need a right triangle technique or something like that. Anyway, that's group 1. Next, we're going to look at group 2 for the inverse properties, a second set of inverse properties. So basically, what happens if the inverse trig function is on the outside and the regular trig function is in the inside? And of course, these are partners, inverse sine and sine, inverse cosine and cosine, inverse tangent and tangent. We're not mixing things up. We're not having, for example, inverse sine and cosine. Then we'll need a right triangle approach like in a later video. Okay, but let's say that theta is an angle. Now, when do we have these clean inverse properties? If you input theta, when can we get theta as our final output? If the inverse trig function is on the outside and the regular trig function is on the inside. Well, this angle theta is going to ask inverse sine. Again, it's going to ask the outer function, am I in your range or not? And if theta is in the range of this outer function, in this case inverse sine, then theta will be the output. It will be the answer. It's what this simplifies to. Well, what is the range for inverse sine? If you think of the unit circle, the range for inverse sine goes from -π/2 down here up through +π/2 up here. That's the range for the inverse sine function. So if theta is in that range for inverse sine, then theta gets spit out. Otherwise, what happens if theta is not in this range for inverse sine, then one of several things could happen. If not in the range for arc sine, then what could happen? There are actually several possibilities. First of all, the answer could be a quadrantal angle, like pi or 3 pi over, well, actually, no. If theta is not in the range of the inverse trig function, what could happen? What are the possibilities? First of all, okay, the answer could be a quadrantal angle, although pi and 3 pi over 2 and 2 pi, those are not in the ranges of these inverse trig functions. The point is, what is the deal if theta is, for example, pi or 3 pi over 2, then the answer will be quadrantal. All right, so your answer could be quadrantal. For example, if theta is pi, sine of pi is 0, and the inverse sine of 0 is 0. 0 is not pi. The output is not the input. Again, if you put a pi in here, then the answer ends up being 0, and these are not equal. The answer is not theta, your input, but the answer is quadrantal. All right, that's one possibility. But what if you don't have a quadrantal angle? Then the answer could actually be a brother, or a co-reference angle, a brother or a co-reference angle, an angle with the same reference angle. So for example, if you input 5 pi over 6 in here, it turns out that the final answer ends up being pi over 6, which is a brother or co-reference angle that is in the range for inverse sine. Remember, the final answer for these, okay, will either be quadrantal, a brother or a co-reference angle, or undefined or not real. Again, some examples. If the input is pi, the final output is 0, the answer is a quadrantal angle, but it's not theta, the input. If for theta, we have 5 pi over 6, and you can work this out. If theta is 5 pi over 6, the sine of 5 pi over 6 is 1/2. The inverse sine of 1/2, we're back to pi over 6 actually, which again is not theta, it's not the original input. I'll show you a shortcut later on. Undefined, well, that could happen in the tangent case down here, actually. Here, tangent actually has some restrictions, because if you try to plug in pi over 2 for tangent, tangent will have none of it. Tangent of pi over 2, you're dead right there. That's undefined. The whole thing blows up. So tangent is not so liberal in this case. All right, so again, if theta is in the range of the outside function, which is an inverse trig function, then you get theta if theta is in the range of the outside function. So in both group 1 and group 2, the inside argument is asking the outer function, am I in your range? If it is in the range of the outer function, then the input becomes the final output. It's perfect. It's a great inverse property. It works cleanly. But if, here in this case, if theta is not in the range of that outer function, an inverse trig function, then the answer will not be theta itself. It'll either be some other quadrantal angle, some other brother or coreference angle, or the answer is undefined. All right. Back to these range issues. Theta asks inverse cosine here. Am I in your range? Well, the range for inverse cosine is from 0 to pi. That's like the top half of the unit circle. If theta is in here, then theta is the output. For inverse tangent and tangent, theta asks inverse tangent, am I in your range? Now, inverse tangent is not so liberal. as tangent and inverse tangent were back in group 1. Inverse tangent is not so liberal. See, the range for tangent is all reals. The range for inverse tangent is not all reals. It's only this interval. We don't even pick up the South Pole and the North Pole. We actually exclude the South Pole and the North Pole, but we do get everything in between. The range for inverse tangent is very similar to the range for inverse sine, except the range for inverse tangent is open. If theta is in this interval, then theta is spit out. For example, if theta is pi over 4 or pi over 6 or negative pi over 6, then that angle gets spit out in the end. But if theta is not in this interval, then the answer is something else. It could be a quadrantal angle, some other quadrantal angle. It could be some other brother or co-reference angle. Or, for example, if theta is pi over 2, the answer is undefined. We'll do some examples in the next video.